Day 4. And I've still got COVID, still testing positive. Absolutely ridiculous. Still, we've got this elves business to take our minds off of it. I took a look at this earlier. It's about overlapping ranges, right? So, blah, 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 elves. Each row has 2 ranges, and the ranges refer to like a zone for them to clean up or something like that. And so we've got 2 and 4, 6 and 8. These are the ranges, and you can see they don't overlap. They don't intersect at all. And that's good. That's the situation that we want. However, some of them do overlap, like this one, and that seems inefficient, but we're not asked to do anything about that yet. However, this one, this range is entirely contained within this range. So that's bad because it seems like we could just do this one and then, we wouldn't have to do this one at all. So we've been asked to find out in how many assignment pairs does one range fully contain the other. And this can happen either way around. It can happen here, like where the second one is contained by the first, or here where the first one is contained by the second, but not here. So in this case, there's 2 such pairs. So let's get going with a bit of analysis on this. So this is our input. And note that these might be two digits. So we've got to split on into 2 parts based on the comma. So in this case, we're going to end up with this one, this one, this one, this one, this one, and this one. And this one, we're going to end up with the second of the pair. And we need to work out, so that's the first thing we need to do. We need to have a well, do we even need, that's probably, don't even need to worry about that. So we split that, and then we've got what it appears to me is that if let's take the case in which let's take this case where the first one is biggest, which is this one here. Is it 2, 8? Yeah, so it's this one. Let's take this one. And say, okay, so this one, the first one's biggest. And so there's a if we let the first item be 1 or 0 and then 1, or let's say seg A, is this coding? It comes into 2 parts, A and B. And so seg A B, that's this bit here. And then this bit No. This bit's seg AA. This bit's seg AB. Seg BB. Seg BA. Let me not do this actually. G and F and G. F and L, or start and finish. Beginning and end. No. Start, finish. Start, finish. Start, finish. Okay, so in this case, where the first one, so we're simplifying and looking at where the first one is the wider range and contains the second, if seg A start is before seg B start and seg B start, no, and seg A end finish is after seg A seg B finish, and then we have or on, then seg A is entirely, seg B is entirely within seg A. So let's try this logic out. Let's call this C1 and C2. So C1 is true if segment A, so segment A start is less than or equal to 6, which it is. And then C2 is true if seg A finish is larger or the same as seg B, which is false. Okay, let's try this one. Seg A start is less than or equal to 4, which is true. Less than or equal to 7, true. Less than or equal to 3, true. Less than or equal to false. Less than or equal to true, okay? And true, no wait. So this one's going to be bigger. So is 4 bigger than 8 or bigger than or equal to 8? Is 3 bigger than or equal to 5? No. Is 7 bigger than or equal to 9? No. Is 8 bigger than or equal to 7? Yes. Is 6 bigger than or equal to 6? Yes. Is 6 bigger than or equal to 8? No. So the logic doesn't work so the logic works in this case, but doesn't apply here. Possibly because the latter one is bigger, and it is. Which isn't surprising. I thought that would happen. So we need a different rule. We need to flip the logic somehow. is there a way we can, I mean, we could just try it with both, but both ways around, but is there a way that we can know which is the larger one? So the larger one will always, well, the larger one will always be larger. And if they're the same length, then either logic will apply. We can test that out, but so we need to two minus four is two. 6 minus 8 is 2. Yeah. 2 minus 3 is 1. 4 minus 5 is 1. Is that coming out right? Yeah, it is. Five minus 7 is 2. 2 minus 9 is 2. 2 minus 8 is 1. No, wait, I'm getting this very wrong. Let me rely on my calculator just to avoid making any mistakes. 2 minus 8, 6 and 4. And that's 0 and 2, 4 and 4. And that makes sense, right? Yeah. So the actual length of these is different. So we actually, you know, at this point we say big seg, small seg. And we choose that based on the smallest one. So that's even, this is even, this is even. The big seg is the first one. Small seg is the second one. Small seg is the first one now. So we got to have 4, 6, and 6, 6. And here they're the same. So we got to have extract big small seg. We're going to change this to be big seg, big seg, small seg, small seg, and small seg, big seg. So let's go through these. These are the same. This is not changed. This is changed. So, okay, if big seg S is less than or equal to 4, is 4 less than or equal to 6? Yes. Is 6 less than or equal to 6? Yes. Okay, so this brings us into a good standing. And we can have these be nice and green now. Okay. So our algorithm is looking like Extract big seg, small seg. Y. Okay. Um, is small seg within big. Great. And that's it. So let's try some edge cases here because I'm not entirely convinced. What about just entirely identical segments? Okay, is big seg start less than small seg or equal? Yes. Big seg finish. Yes. Okay, so that one's fine. What else could we imagine? These are totally off and they're fine. One off is fine. One overlap's fine. This is fine. This is fine. I think it's fine. It's just something that I could get tripped up on, you know? Okay, I think we'll be fine. So in terms of my plan of action, okay. Then we're good. Let's switch over to VS Code. Just push my notes over here. Pull this down here. Okay. Oh, get my input. 1,000 items. I think that's fine. This should still run in linear time. Shouldn't be too troubling. And the sample as well. Okay, I think we are good to go. Oh, wait. Let me just make sure that doesn't do anything weird. Copilot is off. No weird stuff, Copilot, please. Fine. Okay. We steal these as well. No, wait, I've got to have, okay, so that one, the small one is first. No, that one, okay, so the big one's coming, all right. The big one should come first. These are the same size though. So let's get one that's six, six, and four, six. Six, six, and four, six should be four, six first, and six, six second, and then 2837 should be 2 and 8 first, and then 3 and 7 second. Okay. Sorry, that's just my computer. I think. Yeah, it is. Very irritating. Okay. Um, sure there's a nicer way of doing that. Ah, 2, 4, 6, 8. Fine. Okay. Um, Pay more attention. Ah, okay. Okay, that gets us there. Come on. Focus, focus, focus. Okay. So the trial should be 2. Don't want that yet. Big seg, small seg. So the big segment should be coming first, which it now is. Okay. Two, 4, 6, 8, 2, 3, 4, 5, 5, 7, 7, 9, 2, 8, 3, 7, 4, 6, 6, 6, 2, 6, 4, 8. Perfect. And now we need to write a small seg within big. Big, small. Okay. If big seg, is that right? Yes. It's less than or equal to small and big 1 is greater than or equal to small 1. Okay, that's good. Great. Or I win. Okay, 441. Let's give it a try. $17.49. A few silly mistakes there. So that means that 12 minutes and 10 seconds. I can do better than that. Let's look at part two. It seems like there's still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. Yeah, that's one of those things that seems simple, right? I don't know if it will. In the above example, the first two pairs don't overlap, while the remaining four pairs do overlap. In how many assignment pairs do the ranges overlap? So we should be getting 4. The ones that should be passing are 5779, 283. Okay. 5779, 2835, 2837, 6646, 2648. Okay. So it's not a simple or. Otherwise, this would be true. So in this case, the start, the start of the second is before the end of the first. Let's actually use a diagram for this. So we're looking at 567 and 789. 9. Okay. Let's get rid of the 0. 567 and 789. So in this case, whatever. 5, 6, 7, and 7, 8, 9. So we can say that in this case, what can we say about this? Well, we can say that the last the small seg start is less than, or actually, or equal to small, let's say last seg, first seg, end, finish. So we can say that we could say that about this too. That doesn't mean anything. So we could say that about this. What if we move back? The last segment start is less than the finish. Okay, fine. Last seg start is, yeah, okay. So it's still true. It remains true even back here. So actually we've got another condition that we need, which we need the last segment's start to be is greater than or equal to first seg start. So in this case, we've got, okay, is the start of the second segment greater than, less than or equal to the finish of the, yes, so it's before the finish. Last segment start, is it greater than or equal to the start of the first segment? Yes, it is. Is it here? No, it falls foul of, let's start numbering these. Let's give them F2, F1. So it's true. If it passes, so it's true for F1, but false for F2. Whereas here it's true for both of them, true for both of them, true for both. Last segment is less than or equal to okay, yeah. And it's definitely still great. Still after that. Okay, here. Last segment start, that's 8, is less than or equal to the first segment's finish, which is not true. Okay, so this is good. What about if we have it bigger? What about if it's the same size? So this is totally about the size of, so actually the size of the last segment doesn't make any difference. This doesn't change the start, this doesn't change the start, this doesn't change the start. However, if we do this, what do we get? So in this case, last segment start is less than or equal to the first segment's finish. Last segment start is not greater than or equal to first segment start. No, it's less than it. It's less than it, but it still overlaps because the last segment's finish is greater than or equal to the first segment start. So now let me go back to this example. Is the last segment's finish greater than or equal to the first segment start? Yes. It finishes at 5. In this case, Is the last segment finish greater than or equal to the first segment's start? Yes. In this case, is the last segment's finish greater than or equal to the first segment's start? No. That's good. This case, still the same, doesn't change anything. Doesn't change anything, I don't think. Last segment start is less than or equal to the first segment's finish. Yes. Last segment's finish is greater than or equal to the first segment's start. Yes, it is. So the finish is 7 and the start is, yeah, fine. And then that doesn't change here either. Well, actually, is the last segment's start less than or equal to the first segment's finish? No. No, it's not. No way it is. Last segment start, is it greater than or equal to the first? No. Is the last segment start, which is 4, less than or equal to the first segment's finish? 7. Yes. Is the last segment's finish greater than or equal to the first segment's start? Yes. So there's a kind of X relationship here, which is, well, actually, let me see if I can make these arrows proper. What I'm wondering about is there is there some sort of geometric relationship here? Which clearly Excalibur is unable to comprehend. I think there might be, because at this point, these, oh no, they do cross over. Anyway, who cares? Okay. Now, what about if we play around with the other one? What about if we have this? I feel that we're going to need to have a kind of another double rule here. Okay, is the last segment's start less than or equal to the first segment's finish? Yes. Is the last segment's finish greater than or equal to the first segment's start? Yes. Or is this enough then? I don't actually know if it's enough. Let's find out. Let's try and do it on all of these. I'm going to get rid of these, I think. Don't need those. I'm not going to worry about this for now. I'm just going to have first, well, it shouldn't matter the order, so I can just keep the order the same. I haven't come across anything that affects the order yet, so if we find that out, that'll be good. But we might want to try it in reverse as well. Okay. Actually, I'm going to get rid of these. I just think I'm going to be tripped up somehow. Okay. Is the first segment start less than or equal to the first? Is the last is the last segment start less? So is 6 less than or equal to 4? No. Is 4 less than or equal to 3? No. Is 7 less than or equal to 7? Yes. Is 3 less than or equal to 8? Yes. Is 4 less than or equal to 6? Yes. Is 4 less than or equal to 6? Yes. Is 1 less than or equal to 1? Yes. Okay. Last segment finish greater than or equal to first segment start. Okay, is 8 greater than or equal to 2? Yes. Is 5 greater than or equal to 2? Yes. Is 9 greater than or equal to 5? Yes. Is 7 greater than or equal to 2? Yes. Is 6 greater than or equal to 6? Yes. Is 8 greater than or equal to 2? Yes. Is 1 greater than or equal to... Yes. So, and I know these ones overlap. So in which case, you know, this adds up, right? This passes the... This passes the right ones. But I sort of want to end up with a... This is a false and true, so it should be an and. What about the case where this first one's true? So the last segment's start is less than or equal to the first segment's finish, which this is. Last segment start is less than or equal to the first segment's finish, which, yeah, this is. And the last segment's finish is not greater than or equal to the first segment's start. So this sort of case, which we don't have in our list, I think. No, we don't. So let's try adding one. This would be 7, 7, 5, 6. And in this case, the last segment's, so last segment start, first segment finish. Is 5 less than or equal to 7? True. Come on. Last segment finish is greater than or equal to first segment start. Is 6 greater than or equal to 7? No. So it comes out false, which is how it should be. Can it really be this straightforward? Dramatic irony intensifies. I am pretty sure that it will, well, am I sure that it will work? I can't think of any other examples. Okay, plan of action. Copy in, extract, big, small, seg, just use as is. We can take it out if we end up in trouble. Implement is overlapping. And we're trying to count in how many assignment pairs do the ranges overlap. copy in and implement main loop. And the number we're going for is 4. Okay, let's try it out. Switching to VS Code. Get my notes across the way. My rules up. Okay. Right. Let's start the timer. Two, four, six, eight, 2, 3, 4, 5, 7. ASMR 2837 6646 2648. Now there's something we haven't explored yet. The ASMR potential of Advent of Code. Probably someone's done it. Okay, and this one should be false. Great, okay. Okay, that's a relief. I really thought that wasn't going to work. That's probably a sign, actually. I should plan better. Okay, and we're going to have is overlapping here instead. If I can actually copy properly. This should be 4. And then 861 is the answer. Let's try it out in 861. Please be right. Okay. That was a fast one. 26, 23, not blurred. So that's 3.5 minutes, thereabouts. Okay, great. So that puts us in number 4, fine. And I can end this recording.